Welcome to The Explainer. Today, we're going to tackle a question that I think is on a lot of people's minds. Why did managing data get so incredibly hard? To really get our heads around it, we need to start thinking like an architect, because building a modern data system, that's not just building a house anymore. It's like building a skyscraper in an earthquake zone.
Okay, so let's just dive right in. The big question, right? Why is everything so ridiculously complicated now? I mean, what happened to the good old days? The simple databases, the tools that just worked. Where did they go?
Well, here's the thing. The game has completely changed. Our data just isn't a neat little spreadsheet anymore. We've gone from building a simple house to architecting a full-blown skyscraper. And here's the kicker. It's a skyscraper built in an active earthquake zone. It has to handle these constant, massive tremors, which is just a flood of unpredictable data coming at it from all sides 24/7.
So if we're going to build this skyscraper, we have to start with the absolute basics. Before an architect even thinks about pouring concrete, they have to live by certain core principles. These are the non-negotiables. Think of them as the laws of physics for our data building. They're what's going to keep the whole thing from crashing down.
First up, and this one is absolutely crucial, is scalability. It's all about planning for the future. You have to build a foundation that can handle 100 stories, even if you're only building 10 today. And the way we do that now is by scaling horizontally. That just means adding more regular machines to the team, instead of trying to build one single super expensive giant machine. The analogy is perfect. It's way better to have a big team of construction workers than one lone superhero. Why? Because if one worker gets sick, the project keeps going.
And the next principle? This one sounds a little pessimistic, but it's pure realism. You have to design for failure. Think about it. Our architect in that earthquake zone, they know the ground is going to shake. It's not an if, it's a when. It's exactly the same with these huge data systems. Things will break. A server will go down. A network will hiccup. It's a certainty. So you don't hope for the best, you plan for the worst. You build in all the backups and the automatic recovery systems right from the very beginning.
Okay, so we've got our bedrock principles locked in. Now it's time for the fun part, choosing the master blueprint. And just like with real buildings, there isn't just one way to build a skyscraper. There are a few major competing schools of thought on how to actually design this thing.
And this is maybe the most important takeaway of this whole explainer. There is no single perfect blueprint. It just doesn't exist. It is all about trade-offs. You have to ask yourself, what is this skyscraper for? Are we building a high-frequency trading floor where every millisecond counts and speed is everything? Or are we building a national archive where perfect historical accuracy is the only thing that matters? The answer to that question completely changes the kind of blueprint you're going to choose.
So let's look at two of the heavy hitters. On one side, you've got the Lambda architecture. I want you to think of this as a hybrid powerhouse. It's got two separate engines running at the same time. One is this massive, powerful engine for crunching through all of history to give you perfectly accurate results. The other is a nimble, super-fast engine that's like a live news ticker for what's happening right now. It's incredibly thorough, but, it's a beast to maintain. Then on the other side, you've got Kappa, which comes along and says, whoa, hold on. This is too complicated. What if you only need one engine to do both jobs? It's all about simplification. Let's zoom in on Lambda for a second, because it's really interesting. It works in three distinct layers. First, you have the batch layer. This is your master archive, your system of record. It's slow, but it's methodical. It looks at all the data from the very beginning to give you the rock-solid, accurate truth. Then you have the speed layer. This thing is all about the now. It gives you those immediate, low-latency updates. The real magic, though, happens in the serving layer. It's the part that cleverly stitches together the perfect historical view from the batch layer with the up-to-the-second view from the speed layer. When you ask a question, it gives you one unified answer. Super powerful, right? But you can already see, that's a lot of moving parts. Now, Kappa comes at this from a completely different angle. Its entire philosophy can be summed up in one beautiful phrase. Everything is a stream. And you gotta understand, this was a pretty radical idea. It basically says, hey, that giant historical archive you have, it's not a dead, static thing. It's just a really, really long stream of events that you can rewind and replay whenever you want. And once you buy into that idea, bam, you can just throw away that entire complex batch layer from the Lambda architecture. Everything just got a whole lot simpler. All right, our third major blueprint is the data lake. And its unofficial motto is basically store everything now, figure it out later. Seriously. The idea is you have this massive central repository and you can just dump everything in there in its raw original format. Clean tables? Sure.
Messy server logs? Throw them in. Images, videos, random text files? No problem. You only apply structure and rules to the data when you actually go to query it. Now that sounds incredibly flexible, and it is, but it comes with a huge warning label. Without really strong discipline and governance, your beautiful, pristine data lake can very quickly turn into a murky, unusable data swamp.
So, okay, we've got our principles, we've looked at the blueprints, now we got to talk about the actual construction methods. How do we get the steel and concrete, the data itself, into our building? How does the work actually get done?
And really, it boils down to two core ways of doing things. First, you've got batch processing. The best way to think about this is like building your skyscraper one entire floor at a time. Maybe every night or every week, you run a massive job that processes a huge chunk of data. It's incredibly efficient for giant tasks. The opposite is stream processing. This is like a continuous, just-in-time delivery of materials to the construction site. Data is processed record by record the moment it arrives. So it's a simple trade-off, really. Batch is optimized for huge throughput, and stream is optimized for lightning-fast, low-latency reactions.
Okay, so where is all this going? What's the next evolution of our data skyscraper? Well, the future is all about building a smart skyscraper. One that's more automated, way more efficient, and in some ways can almost manage itself.
And the way we get there is with technologies that are cloud native and serverless. Now, serverless is a bit of a funny name because there are still servers, you just don't manage them. I want you to imagine a skyscraper that is so smart it can automatically add or remove entire floors or hire and fire security staff based on how many people are in the building at any given second. That's what these services do for our data. The system scales up and down on its own, you only pay for exactly what you use, and the massive headache of managing all that underlying hardware and infrastructure, it just vanishes.
So we've walked through the whole process. We've seen the core principles, the major blueprints, and the construction methods for building a modern data skyscraper. And that leaves us with one final, crucial question. And this one's for you to think about. Take a hard look at your own systems, your own data, and ask yourself honestly, is it built on bedrock, ready to handle the earthquakes of the future? Or is it standing on sand,